In this video, we'll be looking at parallelograms. By definition, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. Now, when we typically think of a parallelogram, we think of a rectangle that's been sat on, or kind of sideways. But notice that we can keep both sides parallel and still have, this time, a rectangle or possibly a rhombus. Or maybe even a square. So a parallelogram can be a number of other things more specific, but just the fact that we have opposite sides parallel will give us a parallelogram. Now let's look at the measurements of the sides of BC. And then measure the length of AB. And measure the length of AD. And measure the length of DC. You'll notice that BC is 9.3 and AD is 9.3. So these opposite sides are not only parallel, but they're congruent. Likewise, AB, the measure is 5.5, and DC, the measure is 5.5. So these opposite sides are parallel and congruent. Now if we change the shape, keep an eye on opposite sides, they should remain congruent. Okay, so let's state that over here. Right, opposite sides are congruent. Now let's look at the diagonals. If we draw the diagonal from point A to point C, and then the diagonal from point B to point D, and then it's obvious that the diagonals are not equal to each other. Let me make it more obvious. So this one's obviously longer. AC is obviously longer than BD. So diagonals are not equal to each other, but let's look at what they do to each other. Let's construct the point where they intersect. And then measure the distance there. So this one is 2.7, and then measure this distance E to D. It's also 2.7. So it looks like this diagonal is bisected. Let's check the other diagonal and see if it is. So AE is 9.4. And EC is also 9.4. So the diagonals themselves are not congruent, but the diagonals do bisect each other. Now keep an eye on these measurements and we'll change the shape of our parallelogram. So let's write that. Diagonals bisect each other. Now let's measure angles. Get rid of these diagonal measurements. Now, so looking at it this way, we might think that these angles, these individual angles are equal, but let's go ahead and measure and see if they are. B, A, E. So that's this angle. And E, A, D. That's this angle. So these two separate little angles are not equal. However, we do have parallel sides, so we probably have alternate interior angles congruent. Let's measure BCE. It would be alternate interior with EAD. So let's get a measure on that angle. And yes, this angle is 22.2, and this one also down here. So let's measure DCE, and it is 36.1. So we have alternate interior angles congruent. The sum of these two angles is going to equal the sum of these two angles. So we can say then that opposite angles are congruent. Let's to make sure, let's see about angle ABC. Measure that one. That's the whole angle right here. And then let's measure angle ADC. That's this whole angle right here. So, and let me move my trapezoid around a little bit. We have 89.2, 89.2, so those opposite angles. We also have 51.4 here and 51.4 there, 39.4 and 39.4. So, let me write that over here. Both pair of opposite angles are congruent. And then also keep in mind that this parallelogram can be a rectangle, but doesn't have to be. And it also can be a rhombus, but doesn't have to be. And it can be a square, but doesn't have to be. Right.